Hello everybody. So in this video we will talk about a new chapter, the alternating current. So what is an alternating current, and are we familiar with alternating current or not? And where do we find alternating current? In short, we call it AC. I think you have heard about AC and DC, yes or no? DC is a direct current, the current that you use in your laboratory while doing experiments. All right. But the alternating current is the current that you use at home. In this picture, you can see this is an electrical power line. Okay, so from here, from these wires, the current will go into your homes. So basically, the current that you have at home, the current that you run, that is running at home, that is flowing at home, without it, your fridge will not work, your TV will not work, nothing will work. You won't have your light bulb will not work, your lamps will not work, so on and so forth. So those devices, they make use of alternating current. Okay. Now let us understand further what is this alternating all about, and why is it called alternating current. So basically, when we say alternating, we mean to change direction. This is basically the meaning of the word alternating in this context. All right. So it means if the current is alternating, it means that the current is changing direction continuously. Okay. Not only direction, but its magnitude changes continuously. All right. So we are very familiar with this Ohm's law circuit. Let's say we have a wire, something like this, and here we have the resistance. Okay, and somewhere here, let me make this eraser a little bit small. Somewhere here we have a small gap, and we have a key out here. Okay, so are you familiar with this diagram or not? This is the positive terminal of the battery, isn't it? This is the negative terminal. In fact, this is not a battery, this is a cell. Okay, so the voltage of the cell is V, right? The long line out here, that is the positive terminal, and this is the negative terminal. Here lies the key. Okay, and this is the resistance R. All right. Now, as soon as you plug in the key, what kind of a circuit is this? This is called a direct current circuit. All right, a direct current circuit. Why? Because as soon as you plug in the key, the current will start to flow from the positive terminal, right? The current I will start to flow like this. Okay. And what will be the direction of the current through the resistance? The current will be flowing in that direction. So this current goes along the circuit and it ends up in the negative terminal. So does the direction of this current change as it goes along up, as it passes through the resistance? The direction of the current does not change. Okay. And what about the magnitude of this current? The magnitude of this current is also constant. All right. So if you plot a graph, current versus time. Okay, so we plot a current along the y-axis and time along the x-axis. The graph will look something like this. If the current is 2 ampere, then it will remain 2 ampere from the beginning of time until the end. Okay, as long as you let the current flow. If the current is 10 ampere, then the magnitude of the current will remain as 10 ampere. There is no change in the magnitude of the current. And there is no change in the direction of the current. So this is what happens inside of a direct current circuit. Got it? And this is known as a cell. Okay, this is the symbol of a cell for direct current. Are you understanding? Now let us look at what will happen to alternating current circuit. In an alternating current circuit, you have something like this. Again, we have this circuit out here. Here we have the resistance. Okay, resistance. and here we have something like this, and there's a key. Here the symbol is replaced by this. All right, this is also the voltage. Okay, but this is called the alternating voltage. All right, this is not a direct current voltage, alternating voltage. Okay, so what does it mean, the alternating voltage? It means that the terminal at one time it is plus here and minus here. Then in the next half cycle, now this will become minus and this will become plus. Okay, so this is understood from the graph. Let us draw the graph of the alternating current. We plot the current along the y-axis and the time along the x-axis. The graph is something like this. The graph is something like that. All right, so you can see in this graph that the current from a zero value, it increases until it becomes maximum out here. Then from its maximum value, it decreases until it reaches and becomes zero out here. That is called the positive half cycle. Positive half cycle. Got it? Why is it positive? Because it is in the positive direction of the current, right? And then in the negative half cycle, from zero it increases. This is not decreasing. Okay, this is increasing until it becomes maximum at this point. Again it decreases until it becomes zero. This is the negative half cycle. Got it? So one cycle is from here till there. So this will be half cycle, positive half cycle, and this is the negative half cycle. So you see here the current in the positive half cycle is, let's say, in this direction. Let's say if initially this is plus and this is minus. Okay, so the current in the positive half cycle will be flowing in that direction. Then in the negative half cycle, now this polarity will change. That is the property of alternating current voltage. The polarity keeps on changing. Now this is minus and this is plus. So when this is plus, now the current will be going this way. It will be going that way. So this is in the negative half cycle. So as the current goes in the circuit, what happened to the direction of the current through the resistance? It keeps on changing. All right. So during the positive half cycle, it goes this way towards the right side. That means during this half cycle, and so on, the direction of the current is towards the right side. During this half cycle and this half cycle and so on, the direction of the current is towards the left side. So you can see here that through this resistance, the direction of the current is not constant. It keeps on changing. It keeps on alternating to and fro like this. Understand? And also the magnitude of the current is not constant. It grows, becomes maximum, again decrease, becomes zero. It grows, becomes maximum, decrease, becomes zero. It grows, becomes maximum, decrease, becomes zero, like this. So such a current that is continuously changing in direction and magnitude, this is called an alternating current. Is that clear here? So how do we define an alternating current? An alternating current is that current whose magnitude changes continuously with time and direction reverses periodically. At any instant, it is given by this equation: I is equal to I naught sine omega t, where I here is the current at any time t. That means it is the instantaneous current, the current at that particular time. I naught here is called the peak or the maximum value of the current. And omega, which is equal to 2 pi by t or 2 pi f, is the angular frequency. Now if you look at the graph, this is how the graph looks like. Okay, it is a sinusoidal wave. What kind of a wave is it? Sinusoidal wave, basically because it is a sine wave. Understand? So from here the current grows and then it becomes maximum. This maximum value is I naught. That is called the peak value. This is in the positive direction. That means this is in the positive half cycle. Similarly, from this zero value, the current grows until it becomes maximum. At this point also, it is the peak value, but in the opposite direction. From this point, the current goes till here one cycle. Okay, one cycle. And what is the time that it takes to oscillate one cycle? It takes time t, capital T. So basically, time t here is the time period of the current. On the other hand, the alternating EMF is given by E. Let me write with another color. Take this color. E is equal to E naught sine omega t. Okay, what are these values? Where E here is the instantaneous value of EMF. Instantaneous value of EMF. Then E naught here is what? This is the peak or maximum value of EMF. And omega, this is 2 pi by capital T, which is equal to 2 pi f, is again the angular frequency. Okay, so if we plot a graph of this alternating EMF, we get a very similar graph. Exactly the same. Okay, so let's plot the EMF along the y-axis and time along the x-axis. You will get a very, very similar graph. All right, and this point here, this is the peak value of the EMF. Okay, and similarly here, this is the peak value of the EMF. So basically, this will be plus E naught, and this will be minus E naught. From here till here, this is called one cycle, and the time it takes is capital T, called the time period. So basically, at this point, this will be half of the time period. Okay, so you have to remember the expressions of the alternating current. Which one? This one. I is equal to I naught sine omega t. What is I naught here? I naught is the peak value of the current. That means the maximum value of the current, because I told you before that the value of the current keeps on changing. It is not constant like the direct current. Yes or no? It increases, becomes maximum. Again here it increases, becomes maximum. So I naught here is the peak value or the maximum value of the current. Omega here is the angular frequency, okay? And I is the value of the current at that particular instant of time, called the instantaneous current. Got it? And similarly, the expression of the alternating EMF, E is equal to E naught sine omega t, very similar expression. And if you plot the graph also, you get a very similar graph. What is E naught here? E naught here is the peak or the maximum value of the EMF. Similarly, you can see here that the EMF, it grows, becomes maximum, becomes 0, then again it grows in the opposite direction, becomes maximum, becomes 0. Omega is the angular frequency, and E is the instantaneous value of the EMF at a particular time t. Okay, so I want you to be very familiar with these mathematical expressions of the alternating current.